Stars are immense collections of gas whose gravity is so great that they fuse hydrogen into helium in their cores, releasing a massive amount of energy in the form of light. But stars like our Sun are so massive that they cannot possibly keep themselves up against the pull of gravity, and should, when they form, immediately collapse in on themselves. Because there are clearly stars in the sky, there must be some force holding up stars against gravity. This force actually comes from the light emitted in the core by nuclear fusion. According to quantum mechanics, light can be thought of as a stream of particles called photons. These photons carry energy, so they also have momentum, even though they don't have any mass. This means that when a photon collides with an atom, it gives the atom a little push, as its momentum is transferred to the atom. When photons generated in the core of the Sun collide with atoms in its envelope, this transfer of momentum creates a pressure on the Sun that acts against gravity, keeping it up and shining. This radiation pressure is the reason why stars exist in our universe. But radiation pressure can also affect things outside the Sun too. If we could build a spacecraft that is affected by the Sun's radiation pressure more than it is affected by the Sun's gravity, then a spacecraft would be able to accelerate away from the Sun, powered only by solar photons. This spacecraft would need to carry almost no fuel of its own, and could go virtually anywhere in the solar system we wanted, just by changing its angle relative to the Sun. Such a spacecraft would likely consist of a suite of instruments and equipment in the front, with a massive flat sheet of reflective material called the solar sail at the back. When sunlight bounces off the solar sail, it pushes the spacecraft forward, accelerating it away from the Sun. However, our spacecraft need a truly enormous solar sail to accomplish this. A spacecraft weighing only 1,000 kilograms, enough for only a few simple instruments like cameras, would need a solar sail with an area in excess of 700,000 square meters, enough to cover over 130 football fields. Clearly, creating a radiation-powered spacecraft is going to be extremely challenging. However, if we could figure out a way to make such a spacecraft, we could do more with it than just exploring the solar system. Solar radiation gives enough energy to the spacecraft for it to leave our solar system entirely, and a solar sail of this size would be able to accelerate the spacecraft to around 20% the speed of light in any direction into interstellar space. This high velocity would allow the spacecraft to reach the Alpha Centauri system, the closest star system to the Sun, in only about 20 years. This exact journey is the goal of an initiative called Breakthrough Starshot, which plans to use radiation pressure from an Earth-based laser to accelerate a spacecraft to Alpha Centauri and observe the exoplanet Proxima b, which lies within the system. Radiation pressure could be the best way for humanity to truly explore outside our solar system for the first time.